Hello, this is Minky for the course Probability and Stochastic Process. This is homework 1, exercise 1, sorry. So, this question, the first question, it led us to show that the autocorrelation is real and even. I think I didn't give the process that I didn't prove that it is real. I will write it later. So firstly, we'll prove that it is even. We are given that xt is real WSS. So the autocorrelation tau could be written as t plus tau and t. So with the definition of the autocorrelation, it is the mean value of xt plus tau times xt. And since xt is real WSS, so it only depends on the time interval of 2 times. So it equals to this, and so here, since it is WSS, so the interval is also tau, right? That's why we could write it as this. So then the autocorrelation minus tau is equals to tau, so this is even. Yes, and for the real also, let me change color here. Based on the definition, it equals to t plus tau times xt. We wanna prove it is real, so here then it equals to xt minus tau and xt here. So still the time interval is also tau, so it equals to the autocorrelation of x with the value of tau. So we could prove it is real. Yes. And for the second question, we are going to show that power spectral density is even and non-negative. So here, but also based on the definition, it equals to the integral of autocorrelation times e to the power of minus j omega tau. And then we could write it as 2 terms minus. The first one is cosine omega tau, and the second one is j times sine omega tau. And since this is a odd function, it equals to 0. The integration of this equals to 0. And then we change the lower limit of the cosine omega tau term, so here we times 2. And we know that cosine function is an even function, so we could write it as minus omega tau, and it also equals to the power spectral density of minus omega. So here we prove it is even. For the non-negative part, we assume there is a system that h omega is equals to this. So we calculate the mean value of this was yt squared. And then with the formula, it equals to this. And we take it h omega to here, that equals to 2 pi times this delta function. And with the attribute of delta function, it equals to the power spectral density omega 0, and we know that it is larger than or equal to 0. So we know that it is non-negative. Yeah.